Okay, welcome to the presentation on the Seaborn library by Johannes, Lucas, and me. So before diving into the code, let me briefly walk you through our outline. So we're just briefly looking at the question, what is Seaborn actually? We're then going over to have a quick glance at the Gapminder Data Set, which is the data set we're going to use for creating our plots in this presentation. And we will then have an overview over different types of plots. So we have kernel density estimations, histograms and box plots for univariate data, scatter plots and line plots for relationships between two variables, bubble plots for relationships between 3 or more variables. And then at the end, we have a brief connection to the matplotlib library. And we won't go over each plot type in detail due to the time, but I will briefly explain everything. Okay, so what is Seaborn actually? Seaborn is a plotting library, Seaborn is a plotting library that is layered on top of the matplotlib library, so it can be used for data visualization of statistical data. And it has the benefit that it really interacts well with pandas and data frames in general. And it has already a great number of predefined plots that commonly also require less user input than, for example, the matplotlib library. So if you want to dive deeper into Seaborn, you can also check out the official documentation under this link here. And we're now looking at Seaborn in detail. Okay, so the first step, as always, is to import the library. So we're importing Seaborn as SNS. So SNS is just the conventional shortcut for importing Seaborn into Python. We're also going to import pandas, and we're also going to install and import the Gapminder data set. Okay. Now we have everything set for our presentation. Let us also ignore warnings and check the version of Seaborn. So this is the current version we have installed. And now let's have a quick look at the Gapminder dataset. Okay. So as you can see, the Gapminder set has 6 variables. It's a time series dataset with multiple observations per country over time. And it has 3 substantial variables on the life expectancy, the population, and the GDP per capita in these respective countries to a given time. We can also look at further info when we click here, but we actually don't really need this right now. So the first real Seaborn related chunk here, called Seaborn, again with the SNS shortcut, and we are then setting the theme of Seaborn with the set theme command, and we can here adjust the style and the palette. So style basically just defines the color of the coordinate system, and the palette just defines the color of the plot. So we're choosing white and pastel here. Let us run this. And now we have our theme set for the further analysis. So the first plot type we're looking at is the kernel density estimation, which essentially just plots the probability density function of a given variable. In our case, we are plotting the distribution for life expectancy for the whole data set. And as you will see during the course of this presentation, we will start with a very basic plot and then improve it step by step with adding arguments. Okay, let us run the very first chunk. And we have our very first plot, which is just a distribution of the life expectancy variable for the whole data set. Yeah, and as you can see, we have like the white style and the blue plot color. And in this step, we were directly referring to the column we want to look at. So we're just using the KDE plot function to create the KDE, the kernel density estimation plot, and specifying directly the column we want to look at. So life expectancy in this case, with using the X argument, specifying the data set, and specifying the respective variable. We could create the exact same plot with this chunk, but use the data argument instead. So here we're separating the data from the variable, So we're using the data argument for calling the data and the x argument again for calling the x variable. I won't run this because it will show exactly the same plot as before. The same goes for this chunk here. This also would give us exactly the same plot, but here we would store the respective plot to a new variable called KDE plot. So this is really helpful for the further manipulation of the plot. I won't run this because it will still give us the same plot, but it's really helpful, as you will see in the course of the presentation. Okay, so there are also quite meaningful things we can do. For example, we can customize the bandwidth of our plot with the argument BW. So if we run this, we get our plot like this. So as you can see, the bandwidth here is really low and it doesn't really look smooth. So we can increase the bandwidth. And now our plot looks much smoother. So this really depends on what you want to get and also on the distribution of your data, of course. But just keep in mind, the syntax didn't really change. So we're just using the KDE plot command for creating the plot, specifying the data, specifying the x-axis, and then this is new for this plot, specifying the bandwidth with BW. Okay, so this syntax for the first type of plot will stay exactly the same. We can also, if we want to add a shade under the curve to make it look more appealing, we can of course add this shade by adding the shade argument here in our existing syntax. So we're just adding another row separated by a comma and add shade equals true. And this gives us a new plot with a shaded area under the function. This is particularly important for the next task we want to do when we want to group by a second variable. So for now, we only looked at life expectancy for the whole data set, but what if we want to look at life expectancy for let's say, different continents? Luckily, we have the continent variable in the Gapminder data set, so we just have to add to our existing syntax the hue argument and add hue equals continent, so the name of the variable we want to group. And if we run this and also have left the shade argument on true, we get this nice looking graph, also with shaded areas under the curves for each continent. And as you can see, Seaborn has actually already added a legend for us and also assigned different colors for each continent, so we can easily separate them. So as you can see, we have like 7 lines of code and already a really nice looking graph. To improve our graph a little bit further, we can of course also add a title and X and Y labels. So for adding the title, we're just replicating again our basic syntax for creating the plot. And then we're adding with the set title argument, which comes behind the name of our variable KDE plot. And then we can type in our desired name, in this case density plot, \n for a line break, and group by continent. And this gives us then the same plot again, but now with a catchy plot title. Okay, if we want to add axis labels, we of course can do that as well. So we just have to type in again the name of our variable in which the plot is stored, KDE plot, and then set X label for the X label, of course, which is here life expectancy. And we leave the Y label blank through adding an empty string into the argument. And as a result, we get the same plot again, but now with a nice looking X label. If we want to remove these numbers which don't really say anything meaningful in our plot, we can do this with the set Y tick labels argument and also add an empty string. And now we have the same plot again, but without any labels on the Y-axis. Okay, let's come to another plot type, histograms. The syntax still is very much the same, so we're still storing it in a new variable called this time histogram plot, and using the SNS histplot command. So SNS again just called Seaborn, and the histplot command creates a histplot or a histogram. Here we are again calling the data with the data argument and the x-axis with the x argument, and then you get a nice looking histogram. Okay. Of course, also for histograms we can group. In this case, it's called faceting. So we're just faceting by continent, or in other words, we're separating between continents using the facet grid function, specifying the data and the again the variable we want to group by, in this case the continent, and then plotting life expectancy across these facet histogram variable which we created using the .map command. Okay, so this should give us 5 new plots for each continent. If we want to, we can of course also have life expectancy on the y-axis instead of the x-axis in specifying y instead of x. So as a result, we have now life expectancy on the y-axis and the count on the x-axis. I bet you remember the kernel density estimation from above, so we can also combine these two plots and add a density line to a histogram, so that we have a result that looks like this. And now we nicely combined these two plot types. All we had to do was specifying KDE in our histogram function and set KDE to true. And this gives us this nicely looking kernel density estimation on top of our histogram. There are numerous manipulations we can furtherly do. For example, customizing the number of bins with the bins argument, setting it to 20, so increasing it a little bit, or looking at only one specific range of the plot, for example, just looking at the range between 40 and 70 using the bin range argument. So as you can see here, we're just looking at the range between life expectancy of 40 and 70. We just combined the histogram and the kernel density estimation. There's actually a command which already does this without having to specify the KDE argument, and this is a distplot. So we're just creating a new variable called distplot using the distplot function and doing the same as before for life expectancy. And as a result, we get this combined plot. Okay, with regards to the time, I think I will go over box plots because I think you're familiar with box plots. So the syntax, as you can see, stays exactly the same. We just have to type box plot instead of, for example, here distplot, and this creates just nicely looking box plots. Okay. For now, we only looked at univariate data, but what if we want to look at bivariate data, so the relationship between two variables? Probably the easiest way to do that is to look at scatter plots. So we can create scatter plots quite easily in Seaborn again, just using the scatterplot function, specifying again the data set we want to use, as well as the variables of interest with x and y. And as a result, we get the relationship plotted in a scatter plot, and you can already see that there seems to be a positive relationship between GDP per capita and life expectancy. You can of course also log transform the GDP variable due to its distribution with the set y scale function. So you have to call again the variable in which you have stored the plot and then set the y scale to log it. And as a result, you can now even more clearly see that there seems to be a positive relationship. Okay, an alternative plot for bivariate data are line plots. I will also go quickly over them because we don't have really much time. So as you can see here, this is just a simple line plot with life expectancy on the y-axis and the year on the x-axis. Okay, and of course you can also add a third variable again, for example, the continental group by it. There are also bivariate histograms as another opportunity, but we're also going over this and dive into the more interesting things, for example, visualizing data with 3 or more variables. So for this task, we actually need to also refer to the pandas library. So in this first 3 lines, we just compute the mean for life expectancy, GDP per capita, and population, and also grouping by continent and year again. And then we're creating a scatter plot between life expectancy and GDP again, and also include population size as well as the continent as third and fourth variable. So the size of these bubbles refers to the population size, and the color of the bubbles refers to the respective continent. And again, Seaborn has added nicely a good-looking legend without that we had to specify anything. Okay, I think that's enough on plots. Of course, as you can imagine, there are numerous additional plots you can use and numerous additional arguments. But I think for like 6 or 7 lines of code, this is a very appealing result. And Seaborn seems to be like a good solution if you want to do something like that. Now, to conclude, let's quickly compare Seaborn to Matplotlib. So these two are very closely related, and Seaborn is kind of an add-on for Matplotlib. So as you can see, it's really easy to use and to customize. So that's a big plus for Seaborn. The problem with Seaborn is that sometimes if you want to do something special, which is not supported by like the default functions of Seaborn, you probably need to rely on Matplotlib. So we will illustrate this problem in a second. Let's just before compare the two styles with a kind of basic scatter plot. So you see here the Seaborn syntax and below the Matplotlib syntax. Let's run this. Of course, we have to also import Matplotlib before. And the result looks pretty much the same for both. Of course, the style and the color is deviating a little bit, but if we want to, for example, comment this here out, they should look essentially the same with like minor differences in color maybe. But as you can see, they're essentially the same. But if we're making something a little bit more complex, as for example, this plot here with 4 variables in total, this is really complicating with Matplotlib. So you need a lot of code. It looks really confusing sometimes. And the most problematic thing is that the result doesn't look really appealing. So if you want to do something like this, it potentially makes more sense to rely on Seaborn, as you can see. The problem with Seaborn then is that if you want to, for example, add something like an arrow to point on a specific bubble and refer to it and add its respective country, which it refers to, that's not possible in Seaborn. So if you want to do this, this is essentially what this whole code does. Again, we don't have time to explain all the code, but yeah, you just see that we will have to use some Matplotlib code to add an arrow, and it looks really confusing and a little bit messy. In the end, it works, and then it looks like this. And for example, we point at a random dot. This is Kenya 2007, but we could only achieve that by using Matplotlib in addition to Seaborn. The very last thing is runtime. So we can, of course, also compare runtime for Seaborn and Matplotlib. And as you will see, so fortunately, I already run this cell. It takes some time. So this just simulates numerous plots of observations and then compares the runtime in a new plot created by Seaborn actually. And if you run this, we just plot the simulated plots, high number of plots actually. And as you can see, Seaborn takes significantly more time to plot these simulated plots than Matplotlib. So in terms of runtime, you might want to prefer Matplotlib over Seaborn. Okay, that's it. I think we're just under 20 minutes, which is good. I thank you very much for your attention, and I hope I could explain a little bit Seaborn to you. And have a good day. Goodbye.